So the training of DeepSeek R1, it wasn't just one continuous process, was it? There were multiple stages.
You got it. Their pipeline was pretty sophisticated.
Okay, walk me through it.
It started with the fine-tuning on the cold start data.
All right, the cold start.
Then they moved to the reasoning-oriented RL, similar to what they did with DeepSeek R1-Zero, but this time they also added a reward for language consistency.
So they were trying to fix that language mixing problem.
Exactly.
Okay, what came after the RL?
After that, they did something called rejection sampling on the checkpoint.
Rejection sampling, what's that?
It's a way to generate a new data set for SFT,
Mm-hmm.
supervised fine-tuning.
Right, SFT.
And this new data set had more examples of reasoning, and it also used generative reward models.
Generative reward models. Okay.
Yeah. Basically, they used the model's own abilities to create better training data.
So the model was contributing to its own improvement?
That's right.
That's pretty cool. And then
they went back to supervised fine-tuning using this new SFT data and some other data from DeepSeek V3.
Okay.
And then finally, they did a second RL stage.
Another RL stage, but this time across all scenarios.
That's right, not just reasoning tasks. This stage focused on qualities like helpfulness and harmlessness.
Okay, so it sounds like they really threw the whole kitchen sink at it. How did DeepSeek R1 perform?
The results were great.
Okay, good to hear.
Table 4 in their paper has all the details. On benchmarks like AMI 2024, DeepSeek R1 got a pass at one score of 79.8%.
79.8%, okay.
Which is pretty close to OpenAI's O1-1217 model. And on Math 500, it actually did better, 97.3% pass at 1.
So it's solving these tough problems, and it's doing it really well.
That's right.
Okay, so that's reasoning. What about other areas like coding, or just general knowledge?
In coding, it was amazing. Expert-level performance on code forces, 96.3% percentile, 2029 ELO rating.
So it could code with the best of them.
It could. And on knowledge benchmarks like MMLU and GPQA Diamond, it was also really good, even better than its predecessor.
Okay, so this cold start approach really paid off. They improved both the reasoning and the overall usability.
They did.
Okay, now let's talk about distillation. What is that?
Distillation, it's a way to take the knowledge from a big, powerful model and transfer it to a smaller model.
Okay, so it's like sharing the wisdom. Why would they want to do that?
Well, they wanted to make these reasoning abilities more accessible.
More accessible, okay.
Smaller models are easier to run, less computationally demanding.
Right, not everyone has access to those massive supercomputers.
Exactly. So they took DeepSeek R1 and they tried to transfer its knowledge to smaller models from the Queen and Llama series.
Okay, so how did they do that?
They used the 800,000 or so samples that they had curated for DeepSeek R1's training, and then they just fine-tuned the smaller models using this data.
Just fine-tuning, no RL this time.
No RL in the distillation phase, just SFT.
Okay, interesting. So how did the distilled models do?
They did really well.
Okay, that's good to hear.
Table 5 in the paper, it has all the results. DeepSeek R1 Distill Qwen 7b, that's a 7 billion parameter model, it actually outperformed much larger non-reasoning models.
Really? So it was smaller but smarter?
You could say that. And the 14 billion parameter version, it even beat QWQ32B preview.
Okay, so it's performing above its weight class.
It is. And the 32 and 70 billion parameter models, they were significantly better than OpenAI's O1 Mini on most of the reasoning benchmarks.
That's impressive.
It is.
So it sounds like distillation is a very effective way to get strong reasoning in these smaller, more practical models. The paper also compared this to directly applying RL to smaller models, right? What did they find there?
Yeah, that's in Table 6. They did direct RL training on a Qwen 32B model.
Qwen 32B.
Okay, and they called it DeepSeek R1-Zero Kin 32B. The performance was decent, about the same as QWQ32B preview, but the distilled version, DeepSeek R1 Distill Kin 32B, it was much better across all the reasoning benchmarks.
So what's the takeaway there?
Distillation from a strong model is a better way to boost reasoning than direct RL on a smaller model.
Okay, so if you want a smaller model to reason well, teach it using a bigger, smarter model.
Exactly.
Now, I know the paper also talks about some things that didn't work out so well.
Yes. It's always good to learn from those too.
What were some of the approaches that didn't pan out as expected?
Well, they tried using something called a process reward model, a PRM.
PRM, what was the idea there?
The idea was to reward the model not just for the final answer, but for taking the right steps along the way.
Makes sense.
But it was hard to define what a correct reasoning step is in a general sense. And figuring out if a step was correct, that was a challenge too. Automated methods weren't good enough, and doing it manually just wasn't feasible. Plus, there was always the risk of reward hacking.
So the model might have learned to look like it was reasoning correctly without actually understanding.
Right.
Okay, what else did they try?
They also tried Monte Carlo tree search, MCTS.
MCTS, that's used in games like Go, right?
Yeah, it's very effective in games.
So how did they try to apply it here?
They wanted to use it to help the model explore different solution paths. They had the model generate tags for the reasoning steps,
Okay.
and then they used a value model to guide the search.
And it didn't work.
Well, they had problems scaling it up.
Scaling it up.
Language models had this huge space of possible token sequences, much bigger than a game like chess.
Right.
And training a value model that could effectively guide the search was too difficult.
So even though MCTS can help a model explore options, using it to actually improve the model's reasoning, that was a bridge too far.
Exactly.
It's fascinating to see that even techniques that work well in other areas of AI, they don't always translate smoothly to these large language models.
That's right.
Well, this has been an incredibly insightful look at DeepSeek AI's research.
Yeah, it's some groundbreaking work.
So for our listeners, let's recap some of the key takeaways. Reinforcement learning, it can really unlock powerful reasoning in LLMs, even without any human-annotated data at the start.
It's impressive, isn't it?
It is. And combining that RL with curated human data and then using distillation to transfer that knowledge to smaller models, that seems like a really promising path forward.
Absolutely.
And then there's that aha moment, where the model seemed to figure out a better way to approach a problem on its own. That really highlights the potential for AI to develop sophisticated problem-solving strategies autonomously.
Yeah, that's fascinating.
It raises some really interesting questions. What happens when AI starts developing its own approaches to problem solving, maybe even surpassing our current understanding of what good reasoning is?
That's a thought-provoking question.
It is, isn't it? What challenges and opportunities might that bring? It's something to think about. For more enlightening conversations, please like, share, and subscribe. Thank you.